Accept a top-notch collection, performed by utilizing a never-ending scope of stars, planets, and moons, all playing together delightfully. At any value, there's one explicit segment of this gathering that has shocked space experts for a fundamentally significant time period. Exoplanets are conventional planets that exist outside our planetary system, stowed away somewhere deep inside the Milky Way. You may be flabbergasted to find that among the gigantic scope of cosmic objects, there are exoplanets so like Earth, so tantalizingly similar yet confounded, that they may be our planet's divine dual. We dive into the enchanting space of Proxima b, found approximately 4.2 light-years away. The James Webb Space Telescope is enhancing our understanding of these heavenly secrets and strategies. Consider a moment when your mind ventures across the enormous vastness of our galaxy, the Milky Way, which is home to more than a quadrillion exoplanets. This number has 15 zeros. To put this number in context, if each of these exoplanets were the size of a grain of sand, we wouldn't just fill the Grand Canyon. We'd have enough to create another landmark on Earth. A Grand Canyon 2.0 that could stretch for miles. It's astonishing that around 20% of these eminent bodies have been identified as Earth-like in terms of geography and atmospheric structure, meaning there might be a 1 in 5 chance of finding a planet that's a carbon copy. And the story doesn't end there. Close within these planets, there could be another quadrillion moons, hard satellites like our moon, caught in a gravitational dance with their parent planets. If you somehow manage to imagine finding another celestial body in space that harbors life, or could do so, the universe offers a surge of opportunities. Now that we've spread out the canvas of unimaginable scale, it's time to introduce the expert tool prepared to paint its intricate details, the James Webb Space Telescope. This glorious Sherlock Holmes, with its enhanced focal lens displaced by adaptable chief centers, surpasses even the most advanced optical devices. We're not discussing any ordinary lens. Its 6.5-meter primary mirror is 2.7 times larger than Hubble's. Imagine the incredible detail it could capture, even in the smallest burst of a star billions of light-years away, and then analyze the details of orbiting planets. What makes the James Webb Space Telescope revolutionary isn't just its seeing power but also its advanced technology, such as cutting-edge sensors and spectrographs. These tools can do much more than just observe. They can analyze and interpret the light signatures emitted or reflected by celestial objects to determine their chemical composition, density, or even mass. Acting as a cosmic detective, they can ascertain whether a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope has the potential to answer these questions, elevating it from a simple observer to a scientific genius. It's not just an improvement over its predecessor, Hubble. It's more like a quantum leap. If Hubble's discoveries amazed you, prepare for a genuine celebration of groundbreaking revelations. As we broaden our gaze across the intricate landscape of the universe, it's worth focusing on one specific superstar within the cosmic display: Proxima b. Since its discovery in 2016, this fascinating planet has stood out as a Shakespearean legend, full of unpredictability and intrigue, captivating astronomers and anthropologists alike. What's all the excitement about? At first glance, Proxima b is located in our galactic neighborhood, just 4.2 light-years from Earth. To put it in perspective, if you could break the usual speed limits and travel at the speed of light, you would arrive in just over 4 years. About the same amount of time it takes for your favorite TV show to enter reruns. But let's delve deeper into why this proximity is so significant. We're exploring a universe that stretches over 93 billion light-years from one end to the other. So finding a planet so close and so promising for scientific investigation is like finding a diamond in a mountain the size of Everest, a gem that probably holds secrets about life itself. In the grand tapestry of the universe, Proxima b is a complex thread, offering us enormous clues that could redefine how we understand habitability and existence beyond Earth. It's not just Proxima b's closeness to Earth that excites seasoned experts, but also the captivating evidence that this planet isn't just Earth-like. It could be Earth 2.0. Proxima b sits conveniently in what astronomers call the habitable zone of its parent star, where conditions are neither too hot nor too cold. Allowing liquid water to exist on its surface, a key ingredient for life as we know it. This delicate balance makes Proxima b a tantalizing candidate in the search for extraterrestrial life. However, the story of Proxima b is not without its complications. Its parent star, Proxima Centauri, is a red dwarf, a type of star known for its intense flares of radiation. These powerful bursts could potentially strip Proxima b of its atmosphere, rendering it inhospitable to life. Despite this, scientists remain optimistic, as Proxima b's potential for habitability continues to fuel groundbreaking research. Adding to the intrigue is the planet's size and composition. Proxima b is roughly 1.2 times the mass of Earth, suggesting it could have a rocky surface. If it possesses a magnetic field similar to Earth's, it might shield the planet from harmful stellar radiation, preserving its atmosphere and any potential lifeforms. The James Webb Space Telescope plays a critical role in unraveling these mysteries. With its advanced spectrographs, it can analyze the light passing through Proxima b's atmosphere, if it has one, to detect the presence of water vapor, carbon dioxide, methane, or even oxygen, molecules that could signal the presence of life. Furthermore, Webb's unprecedented sensitivity allows scientists to observe Proxima b's orbit and determine whether it experiences tidal locking, a phenomenon where one side of the planet always faces its star. If Proxima b is tidally locked, it might have a permanent day side and a night side, creating extreme temperature variations. Yet, even in such conditions, a narrow twilight zone between the two hemispheres could harbor life. The search for life on Proxima b is not just a scientific endeavor but a philosophical one as well. It challenges us to ponder profound questions. Are we alone in the universe? Could Proxima b be a glimpse of humanity's future? A new home among the stars? As our technology advances and our understanding deepens, Proxima b remains a beacon of hope and curiosity. It reminds us that the universe is vast and full of possibilities, urging us to continue exploring, discovering, and imagining what lies beyond our small corner of the cosmos. In the coming years, as the James Webb Space Telescope and other missions focus their gaze on Proxima b, we may finally unlock its secrets. Until then, this enigmatic exoplanet continues to captivate our imagination, standing as a testament to the boundless wonder of the universe. Too warm nor excessively cold, yet spot on for fluid water to exist. Consider cascades, wandering streams, huge lakes, and conceivably seas as profound and strange as the Mariana Channel. Anyway, before we begin dreaming about heading out to Proxima, we should consider several of its quirks. Driving a solitary day on this spellbinding exoplanet endures an amazing 11 days. Imagine first light that presents not just another day but unfolds slowly, resisting the shift to evening, with dusks that linger, creating brilliant hours that photographers long for. While it sounds idyllic, it also has tremendous implications for its environment and livability. How would human biorhythms conform to the patterns of light and dark on Proxima b? Would we really need to eat 3 or 4 times as much in a single day on that planet? Could we sleep the same way on this exceptionally uncommon world? The straightforward patterns of life, as far as we know them, could be simultaneously tantalizingly similar and frustratingly unfamiliar. It's like nature is giving us an enigma wrapped in a conundrum, testing our understanding of what makes a planet habitable. You might wonder how we can obtain accurate and reliable information about a world we have never visited. The James Webb Space Telescope demonstrates all its capabilities like a massive Swiss Army knife. It's more than just a telescope. It's a complex research lab in the vacuum of space. Thanks to its cutting-edge technology, astronomers now not only observe planets but analyze them through a prism of scientific tools that could make CSI labs seem basic. Using advanced spectrographs, the Webb telescope can analyze the light emitted and reflected by these distant planets. Every element or compound in a planet's atmosphere absorbs or emits light at a specific frequency. By focusing on these patterns, scientists can perform a remote biopsy of celestial bodies, determining atmospheric pressure and density as well as the possible presence of compounds essential for life, like water, organic carbon molecules, and even oxygen. Astrobiology isn't just cosmology. It's space forensics. We don't passively wait for clues to come to us. We actively seek them, analyzing the atoms and molecules that make up these complex worlds. The Webb telescope isn't just an eye in the sky but a highly specialized research lab, detective, and extraordinary investigator all in one. It allows us to test our hypotheses about alien worlds and turn them into methods to confirm or deny them, transforming our understanding of what might exist beyond our blue dot. Just when you think you've peeled back the most beautiful layers of this cosmic onion, the story takes an unexpected turn, much like in any sci-fi thriller. Scientists using the James Webb Space Telescope detected something astonishing from Proxima b, a signal so surprising that it reverberated throughout academic halls and social media. Dubbed a potential technosignature, it was an electromagnetic burst so complex and intricately patterned that it could suggest the presence of an advanced civilization. The collective heartbeat of humanity seemed to pause at the height of a discovery that promised to reshape our understanding of reality. Could the signal be the real evidence that we are not alone in the universe? And just as quickly as it appeared, the signal vanished without a trace, leaving behind not only a beautiful silence but also a maze of unanswered questions and bubbling theories. Was it truly a transient cosmic anomaly, a random event of infinite coincidence, or something else, deliberate? A coded message, perhaps, or a sign of extraterrestrial intelligence? The single incident cast a somber shadow of mystery over Proxima b, sparking wild discussion and speculation. Was it a fleeting phenomenon, or is it part of a much larger story, more puzzling than we can imagine? But wait, the narrative of our cosmic exploration is far from finished. The ink has not yet dried, and new chapters are still being written. This time, not just traditional experts but also Harvard researchers are leading a paradigm shift. As we continue the quest for extraterrestrial life, they are raising the stakes by turning the James Webb Space Telescope into a sort of giant night vision device. They plan to search for artificial light sources in both the dark and illuminated regions of distant worlds. We're considering bold possibilities, such as detecting artificial versions of cities glowing in the dark like super skyscrapers. Imagine seeing the radiant light emissions. It could be a city buzzing with the presence of an advanced human civilization, broadcasting its glow into the vast cosmic oceans. As we continue to unravel the mysteries of the universe, the hunt for extraterrestrial life takes on new dimensions. Beyond the immediate fascination with Proxima b, our grand curiosity delves deeper into the immense, unexplored regions of space. This pursuit is driven by both technological advancements and a profound desire to understand our place in the universe. Advances in astronomy and space exploration have led to the discovery of diverse exoplanets with potential habitability. Tools like the James Webb Space Telescope, biosignature detectors, and ground-based observatories have expanded our ability to discover and study these distant worlds. One particularly captivating area of study is the search for biosignatures, indications of life. These signs could include atmospheric gases like methane or carbon dioxide, which, under the right conditions, might suggest biological processes. The JWST's capabilities extend beyond basic discovery. Its advanced instruments can measure the atmospheric composition of exoplanets with astonishing precision. By analyzing starlight that filters through an exoplanet's atmosphere, scientists can detect chemical markers that could indicate the presence of life.